Hi, my name's AJ Soni. I'm going to be demonstrating a platform that I designed called Enjector EnX. Its purpose is to pipeline intelligent processes. And there's two types of processes that are pipelined by this system. There are non-deterministic processes, which are managed by the AI agents. And the purpose of these kind of pipelines is to mine the unknown unknowns that a business could or may face. And these could be risks, they could be opportunities. So the idea is to actually identify those and actually exploit them or mitigate the business for that eventuality. And the other type of business process or pipelines you can create are deterministic. These are the things that are well defined and they can be executed and explainable. So the system allows you to mine unknown unknowns towards something that's known knowns. So that can be exploited. I'm now going to give you an overview of the system architecture of the platform. The first layer is the application layer. This is where the user's content can be authored. Here's an example of a wiki being edited by the user. In the background, there's an AI agent which is actually detecting issues in the content being written. In this example here, we're detecting violations in anything that's been written, and the agent gives an explanation why there's a violation and quotes citations for the users to look at. But also part of the agent's capability is actually provide suggested correction, which the user can click on, and in the background the system records that they have auto-corrected this, just from an audit point of view. As the RAG sources change or update, the classification of these violations would change, and that would be bubbled up to the author of the document. So here's an example of from the agent layer, the issue detection agent, which has these kind of capabilities. Its goal is to achieve this. And that's driven by a system prompt, and there's some capability within the agent to actually process that information, get the RAG sources and combine things together. And it has constraints, two constraints in this one example here. We have it must show explanations which are valid and provide the valid citations. The other type of capability that agent has is also provides additional clarity. Can something be clearly, better explained? And again, it gives the explanation and the suggestion. And the other type of capability that specific agent has is the ability to provide, confirm the accuracy of what you've written. And this is quite useful when there's high risk policies that an agent is going to be using. So if there's documents for a RAG source or an instruction for an agent, it's quite important to see what is valid and there's confirmation that this is accurate. The other type of agent that we have, I'm going to demonstrate, is called a sentence completion agent. And its goal is basically very much like code completion. While you're typing a sentence, it actually looks at the different various sources and actually assists you where it can complete the sentence for you. And in this case, while the user's typing, they press tab when the suggested text pop-up comes up. The other type of application I'm going to show you is an environment where the user can set up goals and it's broken down by the agents. So we've got a complicated example here where we have a research analyst where a goal is given, then there's a planning agent which actually breaks down the problem, it decomposes the problem and prioritizes the tasks that need to be done. And because it's connected, this playbook is connected to various roles, an idea maker, web search and reflection, for example, it would actually assign those tasks to those roles. So if we have a look at this example here, we have a Kanban board broken down that the plan is using, and these agents are assigned these tasks. And all their conversation and all the things, all the working outs are kept within the context of that task. And once that task has been completed, we have another agent which is called the judge, which reflects whether or not the definition of done of that task has been done by the worker. And what's done and what not done is fed back to the planner And the planner can go through a refinement stage and change the backlog, reprioritize it, or even remove tasks which are unnecessary because it's already being accomplished. So the playbooks themselves can be configured in different ways. The users can actually define their own playbook. So I'm going to show you a drag and drop environment where you can actually test, go backwards and forwards, and actually test out different playbooks. So here's some examples of classic AI playbooks. These are the agents themselves. The other two layers we have are the tool layer, where all the verbs are kept. These verbs are exposed to the agents as well as the application layer. They manage various aspects of the system. And the key thing I want to address is all conversations, all playbooks, all agents, all the interactions are done through these verbs. And these verbs can be written in different languages. So I support about 9 languages in this platform. Python, C++, C#. The main reason for these different language support is because that integration is a painful exercise, and we don't expect everybody to move all their code to Python. So we have this orchestrator, which is called the Adaptive Distributed Computing Orchestrator, which basically allows you to wrap your existing libraries written in whatever language. And with the wrapping, you just decorate the functions as verbs, and the system will automatically detect the function signature and see what the input arguments are, and also detect what the output is, and it become a verb within the system. And it's basically drag and drop into a folder your Python function or your R function, and it'll automatically build, compile, look at dependencies, and just bring it become alive. So once a verb's in the system, it's available as a CLI, but also a REST API and MCP tool automatically. The other type of verbs we have is memory. We have 3 types of memories in the system. I'm only going to demonstrate 2 today. The branching of conversations. So we have a normal conversation. If you put all the agent conversation in one branch, you can get context rot, poisoning of the conversation. What we do in the system with Kanban boards is actually take the conversation, branch it off, and get rid of the information that we're not interested in, the working out, and just put the final answer on the parent branches. And the other type is RAG, classic RAG, where a document is broken up and there's vector searching. There's one other, which I won't demonstrate in this video, is graph RAG as well. I'm going to give you an example of a generic playbook. This is a very simple example where it's given a goal. There's a planning agent that will break down that goal into tasks, a Kanban set of tasks, and assign those tasks to the various workers. I've just put a few workers in there, but you can have specialized workers doing particular things. One exciting one is backtesting and actually creating new algorithms and new code and testing that. Once the work has been done by these workers themselves, the work output is given to a judge, and the judge will take the task that was assigned by the planner to the worker, and it's evaluated whether or not it's achieved the work or not, and that feedback is given back to the planner. The planner can then do a refinement and reprioritization, and then decide whether or not further work needs to be carried out, or just finish. And the finish agent basically, whatever's been researched, it'll create a comprehensive document which will get validated, fact-checked. So I'm going to run this playbook within the sandbox environment. It's an environment where you use these controls at the top here to actually step through the conversation between the agents, and it allows the user to actually define the prompts and also the override some of the system prompts, even select the models they want to use. In this case, in this demonstration, I'm just using the Google Gemma model, the 27 billion parameter, but you can connect to different models. Again, this sandbox environment allows you to tune that playbook before the playbook is actually deployed into production. And let's kick off the playbook using this button here called Run. The first thing that's happened is the goal is loaded up. and we'll see on the right hand side all the agent conversations that are happening, and it gives you the system prompts as well as the output from the agents, and it's a way for you to actually use these controls going backwards and forwards and tune the configurations to make sure that the playbook is tuned for your purpose. So there are various templates you can choose, but in this case we're using a goal-seeking playbook. So the next thing is we've got, at the moment it's showing that we've received the goal. The next thing that's going to be run when we press step is the plan will be created. So let's do that. So the next thing is we can see here in the conversation, the transcript, is that this is the system prompt that's been given. And here's an example of the Kanban board that we want. So the goal is, can you create a plan for this goal? So that planner will now go and create a Kanban, and what we'll see is the plan being created at the bottom here, with the prioritization and the assignments to the various workers themselves. So here we go. The tasks are being added, as you can see there. Any changes are animated. So we can see here, this one's now been assigned to the web searcher, and the plan has said investigate different strategies, and it's automatically assigned it to the web searcher. And the web searcher is very, very simple. Can you go and perform a web search for this task? So we're going to kick that off, and you can see that it's running. And here's the response. So it's done a web search, and there's some data. It's very simple in this example here. It does a web search, fetches the HTML, converts it to plain text, and what the web surfer will do is actually then finalize take the raw information given the task, and it will actually summarize the information. Now this has been created, and the next stage is we need to take the task and the output of the worker and give it to a judge to evaluate. So this judge will actually, it does various things. It will look at the Kanban task, it'll look at the output of the worker, and it will actually look at whether or not the work has been done correctly, and does it actually satisfy the task. And that feedback, which is just generated here, then goes back to the planner, and the planner will go through a refinement stage and then look at the existing backlog and say whether or not those tasks are relevant, or reprioritize them, or adjust the tasks themselves. And that's what the replanning part of the planner will do. Now this will go round and round and round until it's finished or satisfied, and there's a maximum number of iterations as well built into the system, and those parameters can be controlled by the system level. And then what will happen eventually, which I'll show you in a moment, is we'll let this go round and round, and it'll get to the point where all these tasks are finished, and there's a summarization task that needs to be done, and that will output the result of the findings back into the wiki. Now the output has been sent to the wiki, and what's happening now is there's been the paragraphs have been and the sentences have been validated, so we can see some clarity can be done there, some correct statements are there, and as we go down, as the things are being analysed and tracked, we'll be able to correct any mistakes or refine the research that the agents have actually accomplished.